Hello, everyone, and welcome to the final of TERN's 2020 Ecosystem Observations webinars. We have a lot of people viewing today, and welcome everyone from across Australia and across the world. It's great to have so many people join us today. And it gives me an opportunity as the director of TERN. By the way, I'm Beryl Morris hosting this today. TERN is Australia's Ecosystem Observatory, and so it's with pleasure and indebtedness that I acknowledge the traditional owners and custodians of the lands across Australia on which TERN operates. We pay our respects to the elders past, present and emerging, and recognise their continuing connection with the land, water and culture. Just getting my, so in addition to acknowledging the traditional owners, I also want to acknowledge all of the funders of TERN. We have quite a few of them from the Australian government through to state governments and lots of operating partners of TERN, without which everything wouldn't be possible. In our talk today, which is on standardising environmental information collection and harmonising Australia's approaches. This is such a vital topic to TERN. We started ourselves about 10 years ago with this as our mission. And today we're really pleased to be able to welcome three fantastic speakers to talk about different aspects from TERN's perspective, from the Australian government's perspective, and from a state government's perspective, because there are a lot of us out there that are interested and engaged in this activity. Our first speaker today is going to be Associate Professor Ben Sparrow. Ben is part of TERN. He heads up the surveillance program of TERN that monitors across Australia. And he's going to be followed by Dr. Sandra Walpole, who's the program officer in the Australian Government's Department of Agriculture, Water and Environment. And Sandra's role is actually in charge of, she's responsible for implementing the long-term monitoring and reporting framework for the Australian government's natural resource management investments as part of the monitoring, evaluation, reporting and improvement part of the department. And the last speaker for today, Dr. Teresa Eyre, is Principal Ecologist at the Queensland Herbarium in the Department of Environment and Science. And Teresa is an applied ecologist with a highly skilled team of zoologists, botanists and ecologists within the Queensland Herbarium. And her prime motivation is to help government and land managers make informed decisions on the conservation management of biodiversity through field-based research and assessment. And I'm told that Teresa's pretty good at picking the feed trees for yellow-bellied gliders out of fast-moving vehicles and koalas also. And with no further hesitation, I hand over to Associate Professor Ben Sparrow. Thank you, Ben.
Thanks, Beryl. Let me just sort my screens out here. Right. Thanks everyone for joining us this afternoon. It's great to be able to have a bit of a chat to you about a topic that I'm particularly passionate about. I know the other panel members today absolutely are as well. So, for my talk this afternoon, I want to cover off on just 4 key points. So just a couple of slides looking at how ecological monitoring's changed over the years. Before a few comments on scale and sort of the way we envisage ecological monitoring occurring at the moment. And then a handful of important factors when developing standards, things that we need to consider when we're developing standards. And then just briefly, the advantages of doing that, the reasons you would create standards and the advantages of doing that. So when preparing for this presentation, I kind of thought how my career started. And so back when I started my career, if I wanted to get spatial information, I had to go and look in a big compactors for the appropriate aerial photograph. If I wanted to do some kind of analysis, I had something similar to the middle picture at the top, and I'd set something going and make sure I went and took a very long cup of coffee before coming back. And back then, science seemed to be more of an individual pursuit. So you would come up with an idea yourself and follow that through to its conclusion. The kinds of endeavours I was focused on then were far more local in scale. So erosion's one I've got in the slide. And that led to much smaller scales of work. And the slide in the middle at the bottom was meant to indicate kind of my honours work was an entire thesis written about a paddock. It seems bizarre now, but that's the way things happen. And then through to more localized reporting, etc. What I think is really important is that contrasts to how we do business now. So we all have Google Earth at our fingertips. We have spatial information with a few clicks of a button. I can see where any of our plots are across the country and see all the red dots there. We have amazing amount of computing power at our fingertips that we can access again and click of a few buttons. Our work's more collaborative, so it's more of a team approach now, I guess. Well, at least it's certainly headed in that direction. And so we have groups of people, often multidisciplinary, and I'll touch on that later, all trying to deal with issues. And then down the bottom there, we have large scale issues. We're dealing with unprecedented environmental change and climate change and issues that affect us all. And that leads to larger scale investigations. So where it's quite common, if you look in some of the big journals now, to see investigations that are global, analyses that are now utilizing information, field, spatial information, etc., and the huge computing power to do truly global analyses. But also, I guess, increasingly, we're reporting internationally as well. So we've got, over the 20 years of my career, etc., I think we've done a better job at understanding that we're a small piece of a big puzzle and that we're all interconnected and our problems are truly global. And so I think that changes how we do business. It certainly does change how I do business a whole heap. And so I would argue that research is being upsized. I was looking for a Google Images thing of, would you like fries with that? I couldn't find the appropriate one. So you have to excuse my boring slide. But certainly the scale of investigation, I feel, has increased markedly. Going with that is the kinds of monitoring we're doing, the kinds of questions we ask, and our understanding of how they all fit together. And so this diagram, I think Teresa refers to a similar version in her talk, but leverages off of a paper she did back in 2011 that looks at different scales of monitoring and the kinds of questions they can answer. And so a lot of those questions about why is change occurring, what's the cause of that change, how do we fix change, it's still localized, local monitoring, still very question oriented, very careful design, etc., etc. But the regional scale monitoring really feeds into sort of what's changing and how it's changing, what's the direction of that change, is a larger scale endeavor. And then the where and the when is change occurring is largely taken care of with a whole suite of spatial information now. And when I started my career, they were seen as entirely individual endeavors, but more so we're now understanding that they have an interplay. They are all important questions we need to ask the environment. They each provide some really important information, but most importantly, they're part of a whole system. They complement each other rather than compete with each other. And so this is a diagram out of a paper we've had accepted this year that looks at those different types of monitoring and looks at their strengths and weaknesses. And so you can see the kinds of work I do, and then we've implemented, oh, sorry, my team does, the surveillance team here, deals with standardization a lot because we're collecting similar information right across the continent and need to get that into the hands of users in a reasonably standardized kind of way. So there's a little context, and I think that then leads into the kinds of things we need to consider when we're standardizing, and leads me to some of the things, sort of passionate messages I'm keen to share with you. Is one of the things we desperately need to do is we need to actually measure. So when making this point, I use this diagram. You can see a range of Coke bottles through the years. And if you look at the ellipse on the right, the two Coke bottles that I've tried to show off there are reasonably similar, but the two on the left are quite different. So we don't need to measure to tell the two on the left are different. So that's a massive change, but the subtle change, the differences on the right, I would argue strongly that to be able to actually articulate that to someone, we probably needed to measure to get that information. So massive change, we probably don't need to, but for more subtle change, we absolutely need to measure and understand the accuracy of those measures to truly inform on change. The other thing I'd like to chat about on measuring too is we need to actually measure rather than go with categoricals. So at the top, I'm sure many of the audience are familiar with the Braun-Blanquet system. I started my career 4 years in the bush collecting information in this way, but over time you sort of realize that it's perhaps a little problematic. And so you see the two boxes I've got at the bottom of the slide. The one on the left there is 6% of the box is covered with black pixels, and representing 6% vegetation cover, if you like. The box on the right is 25% obliterated with black pixels. So if that was a vegetation I was assessing using this system, they would both come out at 2. And I think that if you're looking at an invasive weed, for example, or woody encroachment, any of those kind of things, that those two situations are really quite different, and you'd really want to be able to articulate and measure that they're different. That leads us on to methods. So I guess with methods, you need to develop methods that actually enable you to measure the things really importantly. I think one of the things that there's really important, particularly for monitoring, is to be able to relocate where you're going. So we locate a diagram on the left. There's our diagrammatic representation of our plot. We locate all those points with a DGPS because being able to go back and monitor the same point through time is absolutely critical. If our plot were to move or we weren't in exactly the same spot, we can't make the same kind of statements about change. But then also the kinds of things we do with the plots there are measurements. So for example, the dotted lines there get to how we assess cover. So we take 1,000 points to assess cover at the species level, because that's seen as necessary if you need that level of information. The accuracy in measurement, I'd argue too, flows through to what you're actually measuring too. So being sure that you can identify things. And so we've developed a process too that enables us to keep samples and make sure that we're certain about what we're talking about. We're not just doing a visual assessment. There's a way of verifying and making sure that what the species we're talking about is verified, and indeed enables us to track taxonomic change through time too. If any of the species we're working on get changed, we can go back and re-examine the samples and re-ID them if that's necessary. The other point is we have to choose what to measure, and how would we do that? Well, I think that's a really long consultative process. No one has those answers. It's a sort of social thing, and I think we'd like to think that science wasn't a social exercise, but it absolutely is. So we need to source the right experts, give them time and space to discuss all those issues, the kinds of things they think are critical to measure out there in the environment, and to determine those, and then start the process of documenting them. And so here's just a few slides of right in the bottom right, the very beginning of when I got involved with TERN, but through a range of workshops through time, looking at how we collect methods, and then indeed how they'd be analysed, and those kind of issues as well. The other point I wanted to make on this is that it has to be really truly multidisciplinary. And this is the slide I use for that, because I think if you were going in for an operation, my argument is, which of these people don't you want involved? And if you actually think about it a little bit, every one of them is absolutely critical. You might go, oh, budget cuts will cut out the administrator, but then it's likely that the wrong person's having their appendix removed or whatever. So we're dealing with a large complex system, and so we need to make sure we've got a suite of people at the table informing on those methods and the kinds of information that's critical, with a broad range of a broad background, broad range of knowledge that can bring that together in a multidisciplinary way to all head towards the, in the same direction, the same outcome. Once you get to what we need to measure, it's really critical that we make really clear and standardized protocols. So through our journey, we've learned a whole lot about doing that. We didn't get it right from the outset, but we've adapted and developed as we've gone along. One of the critical things is to provide the rationale, give people the explanation about why you're collecting things a certain way. What's the rationale? Why would you do that? And sometimes, particularly when you get to measure, things can take perhaps longer than normal, or certainly different. People would need some justification to change. So the rationale around why you're doing that's absolutely critical. But then also it's critical that you present that information in a way that has got, guidelines and keys for people that have how to do the work, but also is the core part of it's a recipe book. You provide step-by-step basis for people to then take them away and implement them. And then, it's some guidelines on tips and tricks and how to do things easier. But the core part of that is very clearly articulated step-by-step process. And so that the two diagrams on the right are how we do that for our program, but certainly there's a whole lot of work happening in this space at the moment. And I think it's a sort of exciting time for specifying protocols. The other part of that story too is we want to create tools for ecologists to use. So we want to create a suite of manuals, so to speak, a suite of protocols that people can come along and take out the protocol that's of interest to them and then necessary for their work. So a good example might be you're doing a vegetation analysis for some reason. You could take the 3 or 4 components that really inform on, say, vegetational composition, but you're not then obliged to collect all the soils and all that information. But what you do collect is in a standardized way that you can then easily use and make interoperable with others that have collected in that same way. The other thing I would argue too is it saves you time. I mean, so many of us probably started off our careers determining a new method, and I don't think that's so necessary anymore. I think we have a suite of well-substantiated methods. We can actually spend our time out there collecting more data or doing more analysis and spend more time actually achieving the science rather than designing what it is. in the lead up to this seminar, we were asked to comment on citizen science, and it's something I've been involved in a little of late. And I think it's a crucial piece of the puzzle, because I see citizen scientists having two really key strengths. They are able to collect information in much larger areas over much longer periods of time than realistically professional scientists are ever going to be resourced to do. And so there's a real strength there in more places and more often sampling. But citizen science has traditionally also been critiqued for things like lack of rigor or accuracy, or lack of background knowledge, poor data management, all these kind of things. Some of which I think is entirely an unfair assessment, but most of which can now be resolved largely, or certainly helped, with the use of technology. So by developing appropriate tools and putting them in the hands of citizen scientists, and so apps and data management pipelines, etc., along with training programs, I think largely so many of those weaknesses or historical critiques suddenly are much less of an issue, but the strengths remain. So the ability to sample large areas and over time really feeds in a level of information that we're perhaps really desperate for. There was also the point to discuss about how we integrate non-standard or historic protocols, and I think there's several ways to do that, and there's probably a longer discussion here for more technically minded people than myself to get into interoperability of data sets and all that kind of thing. But it comes down, for me, it comes down to two main points. So there are plenty of occasions where you collect information on the same measures, but not necessarily exactly the same method to get that. The example I often use there is our point intercepting. So many of you are probably familiar with how we do that, but you can get similar information by step pointing or wheel point, etc. It's a slightly different method, but giving compatible data. So, and then there's also ways of, there's potentially ways that you can make data more compatible. You can convert it or transform it, etc. But for me, I've always viewed this issue as one of triage. So I'd argue that we need to not worry about this as much as we think. We need to stop the problem getting any worse. So let's deal with standardization now. And then once we've resolved that and all our new information is coming in a nice, consistent manner, then we can, the second step's how we deal with that legacy information, how we would manage that. I have alluded to tooling, but it is something I think plays into the bigger picture here, not just citizen science, but technological advances and the advantages of different tooling, etc. I think are a key piece of the puzzle now. So we collect on an app because with an app, we can completely control our data entry. So you must enter certain fields, you must use the right categoricals, or you must enter the data in the right way using standards, etc. But we can also sanity check that. So we can have rules involved. For example, in our app, you can't put in a acacia and call it a tussock grass because the system realizes that's wrong and prompts you and asks you to get the information right. So there's a real data accuracy component to that as well. There's the data security issue. And so you can automate this system so they automatically send information to cloud-based databases. So a whole lot of that whole data management pipeline disappears. And so ironically, out of all our now 750 plots, etc., the one plot we had issues with data security and then don't have all the data for was the single plot we collected purely on paper in the early days. Apps can help us around a whole lot of the other really simplistic errors that we make with field data sheets. And I was an early adopter here because anyone that knows me realize I've got absolutely appalling handwriting. So transcription errors and those kind of things, having IDs facilitated with barcodes. So you saw the herbarium sample I had on an earlier slide. Our app will actually scan that and know what it is by its barcode. And all those checks and balances on data entry I discussed earlier. Apps can speed up the collection process. Sometimes they do that in the field, not always. Sometimes it's a little more onerous in the field, but they always speed things up if you include all the data management and post-processing. So the transcription and all that side of things is largely taken care of once you head down this route. They have the ability to interact with corporate database store, so you don't have to go and develop your own database, etc. You can use tooling and we can share that with people and make it easy for them to utilize that. Saving a huge amount of time and effort, and back to my point earlier, you can spend more time actually doing your science than designing it and worrying about management of your data, etc. We use it to provide an easy curation interface as well, so it helps there. We have a web interaction with our database to curate things, etc. And that increasingly that's really useful in a distributed workplace. So because it's all web-based, it doesn't matter where your people are sitting, they can do those kinds of activities. And then data delivery and interoperability is not really my strength, but aware of it enough to know that making APIs and enabling others to get at your data, not just themselves, but programmatically, is a real strength, and tooling enables that. And so this is a greatly simplified version of how we do business, but all our data is collected on our app in the field. It automatically gets sent through to our cloud-based database. That's a proper corporate database, but with the web curation tools there, and then it's delivered by a range of ways. We've got an R package that enables researchers to use, to access and do some processing on our data in the package that they're usually doing their statistics on, but also a range of other TERN ways of enabling that data to be publicly consumed. Slide's a little bit out of date. Guru and his team are working really hard on developing some newer ways of doing this. I think training's critical to make sure standards are adhered to and make sure people understand two ways what you're trying to achieve. So, and that's why I've got the two different types of diagrams here too. There's the more theoretical way of why we're doing things, the actual components, etc. But there's aspects of the kinds of work we do that you can't be entirely across until you've actually been out there and kicked the dirt and sat in the hole and sorted that out as well. So whenever we try and do both aspects and make sure that anyone that wants to use our standardized methods have access to training to help them through that, and experts they can call to help them with any problems they might have. But then that standardization, I think, then enables a heap of things. It enables larger scale analyses than we've been able to achieve previously. It enables us to pre-can some of those analyses. So we know the format our data is going to look like, etc. We can prepare and at least semi-automate some of the kinds of analysis we want to do to that. And as a result of that, potentially speed up that analysis process afterwards. Enables greater consistency with our reporting. We can compare like with like, etc. Speeds up that part of the process as well. But enables us to have our data feed up to national and global scales as well. Enables cross-jurisdictional analyses, which is really valuable with organisations that have multiple land holdings in multiple jurisdictions. And that's a point I've made several times, more efficient use of your resources, you get more time doing work and designing it. And so that brings us full circle to the strengths of how we do business now, enabling us to sort of upscale our science by using standardization. And so that's the end of my presentation, but the key point I wanted to make here on my very final slide is I think we're at the right time to achieve this socially. I think as ecologists, we've understand that we can achieve better as teams. We understand the value of standardisation, etc. I think it's an ideal time for us to all pull together and work, push in the same direction. Thank you. I'll just finish my slide sharing here somewhere. I'll find it. And hand over to Sandra. Thank you.
Great. So many thanks to Beryl and Ben for giving me the opportunity to speak today. So I've been having a few technical issues at this end, so thankfully the slides are going to get shared at that end. So I'll just wait for my first slide to come up with any luck. Aha, wonderful. All right, thank you for that. So yeah, as discussed at the outset, I'm going to give a Commonwealth Government perspective on how we're working towards standardising environmental information collection. And we deliver nationwide national natural resource management programs, and so we're working at each of the scales that was outlined by Ben. Okay, next slide, please. So just to give you a quick outline of what I'm going to be talking about today. So just covering off on the emerging priorities at the Australian government level, describing a workflow of biodiversity data uses and needs, what sort of looking back at natural resource management investments and the type of data that's been collected. Focusing on the Regional Land Partnerships Program, because that's our flagship NRM program that we're currently delivering and that my team is responsible for evaluating. Looking at, what are the data standards that we can potentially start to improve and apply in terms of current and future NRM programs. And finally, just introducing some new work that we've just got underway called the Monitoring, Evaluation and Research Network Pilot, which will be starting to test out some of these data standards issues that I'll cover today. So next slide, please. So in terms of key emerging Australian government priorities, so firstly we had the Bushfire Royal Commission, and that final report has highlighted the importance of better quality and more complete and comprehensive biodiversity data to prioritise and invest in the environmental assets we wish to conserve, protect and recover. We've also recently, well, literally just almost completed the EPBC Act review, and this suggests a national supply chain of best available trend data and information to underpin national environmental standards, monitoring, assurance and compliance. We've also had an internal future departmental review, and data and analytics is one of the 8 areas for improvement. And we have what's called the Digital Environmental Assessments Program, which is a key initiative within the department to transform the Commonwealth's environmental assessment and approval process to a user-focused digital platform that integrates systems and data across jurisdictions. And specific to the work that I'm talking about today is the long-term monitoring framework. So this is some work that we commissioned Griffith University to do, and they reported back to us early this year. And that proposed framework aims to ensure effective and robust data collection, management and accessibility to enhance natural resource management in Australia. So next slide, please. So we actually have to go through a number of clicks for this one. So if we think about the biodiversity data workflow, it first begins with the collection of raw data in the field. And as Ben suggested, using apps is the ideal way to do that, to ensure that consistency. Okay, next. And then we have this raw data is then ingested and aggregated into a storage environment, such as our species observation system where it is curated. Next. And it's now available for others to use, analyse and value add by producing new derived information and products. Next. And these new derived data or products also need to be stored somewhere so that they can be discovered and accessed. For example, the Find Environmental Data for visualisation and the Protected Matters search tool. And so each of these steps, the next slide. Each of these steps in the data workflow requires standards to ensure that we collect, analyse and report on data consistently. Okay, next. So if we reflect on past NRM investments and data capture, so the Australian government has a long history in investing in NRM programs, but the reviews to these prior programs has shown that past programs have typically had a focus on activity reporting. There's been a widespread lack of consistent long-term data to monitor NRM outcomes, and it's difficult to assess and quantify the effectiveness of investments. So some of you may be familiar with Merit. So this is the tool that we use to store information on project activities, but no equivalent currently exists for storing and curating ecological monitoring data. Next, please. So I just wanted to give you a quick overview of Regional Land Partnerships, which is our flagship NRM program. So it's a $450 million program over 5 years. It covers off on 54 management units across Australia, is investing in over 210 projects and has a focus on outcomes. And so on the next slide, you'll see that we have a split between environment and agriculture projects, with environment sort of taking the bulk of those. And each of these 6 elements are the outcomes which we're trying to deliver. And so threatened species has the largest number of projects, but we also are looking at threatened ecological communities, Ramsar wetlands, World Heritage, and on the agriculture side, looking at improved land management practices and adaptation to changes in climate and markets. And we have projects geographically dispersed all across Australia, and the RLP projects are delivered by service providers. And this program has switched to a procurement model. So past programs were generally grant-based, but we're now paying service providers to deliver specific actions on the ground, including monitoring. So just to give you a sense of some of the projects that we're funding. So for example, Malleefowl, we're funding 15 different projects across Southeast Australia and 14 salt marsh projects. And so when we sort of look at data standards for current and future NRM programs, which is clearly where we want to be, we might not quite be there yet, but we've got things in place that are going to certainly move us towards that. So as we've already stated, there's currently a lack of consistency in data recorded for NRM investments. The data collected may be incompatible across projects, regions and jurisdictions. For example, if you look at the diagram on the right-hand side here, we've got 5 different projects funded through the RLP for the Australasian bittern, and there's a range of interventions that are being carried out for each of those projects. And you can see that monitoring is being undertaken for 2 of those different projects. But even though we're paying service providers to undertake a range of scientifically rigorous environmental monitoring, we don't know whether we're going to actually be able to aggregate and compare data from different projects related to specific species, interventions, regions or outcomes until we actually receive and curate that data. Next slide, please. Oh, yeah, so we're already here, sorry. Oh, can we just go back a slide? Thank you. And so the data needed to understand, monitor and manage biodiversity in Australia is captured and held by countless government, industry, research, NGO and community bodies. And so one step towards us helping to improve the standardisation for NRM programs is that we are currently in discussions with TERN to develop modules to standardise the way ecological field survey and monitoring data is collected for both current and future NRM programs. And the stuff that Ben was describing to you is exactly, we're hopefully going to pitch that towards what we need for our NRM programs. And this will obviously strengthen the evidence base for analysing, assessing and quantifying the effectiveness of NRM investments. And we also have an intent, we've talked about that citizen science and the NGO perspective. We absolutely want the modules that we're potentially going to develop to be available more broadly to NGOs and other groups that might see them as being useful for applying to their work. And if we just move finally onto the Biodiversity Data Repository project, so as part of the Digital Environmental Assessments program, the Biodiversity Data Repository project is being led by the Geospatial and Information Analytics branch in the department. Some of you may recall that used to be called Eyre, but it's now got a new acronym. And so the BDR is being developed to store and share information collected by proponents and to enable the reuse and sharing of data, which will potentially reduce costs to share data and improve collaboration, which once again is something that Ben emphasised. And so finally, we'll just move on to my last slide. So I just wanted to promote the MER network pilot. And so as part of the long-term monitoring, evaluation and research, as part of the long-term monitoring framework, MER networks have been proposed as a new approach to learn about ecological management effectiveness. And so MER networks will address targeted ecological management questions at national scales, as well as enabling predictions and facilitating improved outcomes in future NRM programs. So running in parallel with the existing NRM program, the Regional Land Partnerships program, we're happy to say that Sparrow and TERN will be implementing a pilot MER network to promote national scale learning about bushfire recovery across different ecosystem types and the ecological effectiveness of post-fire interventions. And obviously a key element to this pilot will be developing standardised on-ground monitoring protocols. So thanks for the opportunity to share that with you today, and now I'll hand over to Teresa.
Thanks, Sandra, and thank you, Ben and Beryl, and thank you to TERN for the opportunity to speak in this webinar today, because I am a really big fan of standardised ecological field data collection, because it's really the only way that we can detect trends over space and time in features such as habitat attributes, species diversity, down to single entities such as densities of greater gliders. So just really quickly, I'm going to provide a brief outline of things that we've learned in Queensland from developing field ecological data collection standards. So focusing on this surveillance tier that Ben brought up before. Then I'm going to quickly go through an example of the value of field-based standardised data to produce continental scale mapping. So this where the surveillance tier talks to this continental scale monitoring tier, and then just a couple of concluding take-home messages. In the Queensland Herbarium, we're responsible for 3 different vegetation ecological protocols. One for which is related to our regional ecosystem mapping, and that's a protocol for the survey, the assessment of vegetation to map regional ecosystem extent and type. And then we've got vegetation condition assessment protocols and terrestrial vertebrate fauna survey guidelines. And the 2 that I've been most involved with and my team have been vegetation condition and terrestrial fauna survey guidelines. Learnings from 20 years of hanging around, coming up with protocols for field-based ecological assessments. I won't go through them all because Ben and both Sandra and Ben have touched on a lot of these, but from my perspective as a state person, having a purpose for the assessment protocol is vital. Training is vital. And also having a really pointy set of attributes that have been shown to scientifically matter and that can be reliably assessed in the field is really, really important. And in the words of Albert Einstein, not everything that can be counted counts, and not everything that counts can be counted. And we really stick by that philosophy. And then, of course, a set of standardized protocols to measure those attributes. So going back to Einstein's not everything that counts can be counted, in developing the biocondition assessment protocol, we've done a lot of testing on the reliability of the selected attributes. And to my total dismay, because it's one of my favourite attributes, large tree with hollows, as you can see here, was so highly variably assessed by different observers that we had to make the painful decision to not include it as an attribute. That's okay, because we've got large trees in there as an attribute, and it can be reliably measured because you actually need a DBH tape to measure them. That's not to say I'm not advocating that large trees with hollows is assessed. I'm just saying that you need a really highly skilled, trained team to be able to do it properly. And if you can't do that, then best to just maybe use something like large trees as a surrogate. So yeah, better to have a small set of attributes that can be reliably assessed. So I'll move on to our example now, which is a project that we've been undertaking the last couple of years to basically map vegetation condition for across all of Queensland's terrestrial ecosystems. And we were given 2 years to do it, so it was a pretty big job. But we did have the biocondition framework, which is site-based. Need to make that spatial. We had that in place. And for those of you who are not familiar with biocondition, in a nutshell, there's 4 important components, which is that standardized assessment method of 10 measurable attributes that reflect condition for vegetation for biodiversity. Those measures are compared to benchmarks from reference sites, and that spits out a score or a metric between 0 and 1, which we can then classify into a 1, 2, 3, 4. As you can see in this Brigalow bioregion, this is just one Brigalow regional ecosystem, 1195. So this is in good condition up here, number 1, through to its conversion into a buffer pasture, which is not so great for biodiversity of 4. Now, I'm not going to go into detail about this, but this is our very simple framework for our modelling. But I did want to just focus on the input data down here, which is our site training data. So it needs to be a condition site information based at the site that relates to regional ecosystems. And I'll just have to say we've got over 1,400 of those. So it's a big job. And of course, remotely sensed data. Model. We're probably going to go down this machine learning route because that gives you a probability of a pixel being a particular condition state. Spits out a condition class map. But as we all know, the old adage about rubbish in, rubbish out, we really want to try and avoid as best we can our training data being rubbish going in, because it's only going to compound output, not being very useful for our purposes. And I'm going to scientifically demonstrate this with my Labrador, Baloo, who is representing our machine model. So here he is looking pretty happy, but he's hungry. Turns into an absolute vicious and voracious, insatiable beast as soon as we feed it some site data or food. In the end, he's happy, but he's still hungry, and it's really quite exhausting. You need a lot of site data. So we've had to think about how we could possibly obtain rapid condition assessment data, and we tortured some of our poor highly skilled vegetation ecologists and mappers back at the Herbarium to all assess the same 35 photo sites of different states, condition states. And outcome was some can do it okay, but it is really driven by experience, how much experience the observer has had by condition, basically. But overall, none of us were very good at picking out condition states 2 or 3. So to try and avoid a rubbish going in, rubbish coming out scenario, we really have to just identify that there is no escaping getting out of the car and measuring stuff like Ben was alluding to earlier. So we've collated a whole bunch of site-based data from our Queensland Herbarium databases, also from very friendly, helpful consultants that use the same standards. So they were happy to share some data with us, which thank you to all of them. And of course, the TERN ecosystem surveillance sites. We came up with 32,000, close to 32,000 sites. However, in the end, we had to just only 1/3 of those were really useful, which is still great. It's nearly 10,300 sites, a few gaps in the Mulgalands and Mitchell Grass Downs. But reasons why we had to discard them, mainly because inconsistent methods, and we were just not able to align in the amount of time that we were given those inconsistencies. Other things like the sites were too old, and for our purposes, that was a problem because there was a condition state change in the meantime, like they might have been cleared or heavily logged or thinned or something, and so we weren't able to use those as well. But the other one is errors in site location, and we're talking about artificial intelligence here. So the machine is taking whatever we're giving it, so we need to make sure whatever we're giving it is really spot on. So as an example, a lot of our sites that we collated were located on roads. I guess back in a few years ago, people might have been a bit tired to get out of the car, just took the geocode from the car. Problem is the machine goes away, learns that this site, which was supposed to represent a state condition of 2, which is pretty good, learned that thought the road was a condition state 2, and so therefore mapped the road as a condition state 2, and we obviously know that's wrong. So the other thing about standardized ecological data, field data, which I find is going to be super important for this project, is explaining the output of the model, because I've got to admit, it's a bit of a black box. What goes in, it's artificial intelligence. What comes out is quite hard to interpret and to explain to a stakeholder on their property or something. But if we've got our standardized data to be able to link to that model output, and as well as link to condition scores, that will certainly help with our communication and interpretation. And of course, keep checking that what the model is doing doing what we want it to do. So concluding messages really quickly, whatever the scale of assessment, a standardized protocol reduces a lot of pain. Ecological data is invaluable. We all know that. We've got to look after it. A centralized database would be fantastic. I reckon we need to revisit the old collaborative models that we used to use in the ACRIS days, for example, to encourage collaboration in the selection, assessment and storage of ecological attributes across all different agencies, from NGOs. We've got a lot of Bush Heritage Australia, for example, that everybody, universities, community groups, everyone's going to be wanting to use different protocols. If we can standardise those as much as possible, it's going to help ecology in the end. And also just a little plea, beautiful animals, look, baby greater glider, so cute, is not to forget fauna is also a component of ecology. And with that, bush pavlovas to all of you out there. Thank you for listening, and thank you, of course, to the team back at Queensland Herbarium, Remote Sensing Centre, and all my colleagues. Thanks. Oh, and I'll hand back to Beryl.
Thanks, Teresa. We've just had such 3 fantastic speakers. It's been brilliant, and I think I've gone a bit green with envy. According to my screen, don't know what's going on there. We have had some nice questions, and I'm not sure who should answer the one about how we integrate it across species so that interactions are discovered. And the example given is that mycorrhizal associations vary across plant species richness, but also older plants then tend to have more diverse and different mycorrhiza than younger plants. So how do we need to redesign our records to capture the age of the plant aspect, or other things that might link to ecological function. Who wants to take that one for a second? Ben, I'm nominating you.
Thanks, Beryl. Yeah, I mean, I think that recording the age of plants either through growth form for those species that sort of indicate their age by their habit, etc., is critical for those kinds of questions. I don't know if we're at the stage we can implement that across the entire country yet, but it's something we should discuss.
Okay, and I have a question also about whether the ALA model would be a good one to use or to extend for all the digital standardisation initiatives. I think this one might perhaps also be Ben or Sandra, I'm not sure. One of you.
I might just kick off. So we, obviously ALA support our merit tool, which is one, as I described, sort of sets out all the activities that are being undertaken for a particular project. And there's potentially merit in applying that for other data standardisation information, but I can't actually sort of go beyond saying it's a possibility, but not something that we've got planned at this stage, if that helps.
Thank you. So the follow-up was that BioCollect might be applicable from ALA, but I think you've covered that one, Sandra. I hope everyone can hear me. There was a question about whether people could hear me. I'm just thinking we've only got a couple of minutes to go, and before I do my couple of wrap-up sentences, I just want to ask Ben, Sandra, Teresa, a quick take-home message from each of you, the thing that you want people to most remember out of your talks. So Ben, it's all about working together for you, I think.
Yeah, absolutely. Look, I think that the most interesting thing about ecology over my career is the social aspect of it. And I think we're coming together as a community now and starting to push in the same direction. So absolutely, I think working together, collaborating in a multidisciplinary sense to achieve these kind of aims is critical, but it's the ideal time to do that.
Sandra, I think you're all about integrating the data.
Yeah, so I guess the take-home message that I wanted to put across was that the true value of dispersed but significant investment in data capture by both NRM investments and through environmental assessments, this can only be realised if these data are brought together into a curated national data set that can offer a single point of truth and provides quality data for all potential users.
Teresa, your take home?
Yeah, thanks, Beryl. I think that we need to critically improve the capture of standardised ecological data across our different geographic scales, as well as the different agencies. The time is critical, particularly given unprecedented activities such as the recent wildfire burns that we saw earlier this year and in late 2018 here in Queensland. If we had, it's difficult for us to be able to monitor trends in restoration and recovery when we haven't got something to work with in the beginning.
Thank you for that, Teresa. So this is the final of our seminars this year, and I think we have ended on such a high note with Ben and Sandra and Teresa giving us a brilliant talk of what's something that is so core to the work at all levels across Australia. For anyone who wants to stay on, we do have another couple of questions, but I just want to say that we are continuing our webinars next year, probably kicking off in around about March. It depends on everything that's happening. So please, thank you everyone. Stay online for a couple of seconds and we'll just ask, we'll answer a couple more questions for those that have got time to stay with us. Thank you everyone. See you next year. Okay, if we're there, we have a question about resolving the tension between standardisation and getting, sorry, my question's disappeared, and identifying the aims and purposes of what we're trying to do, since that might change the method that we're going to use. Does Ben, I think you covered that one. Oh, Teresa.
Yeah, I'll have a quick go. I reckon that's a great question, and I was wondering if somebody was going to ask that, because I could see that there was going to be an issue there in what I put up in my slide. That's absolutely going to be attention, but I really think that we've come to a point where there is going to be certain components that will be assessed or measured in the field that can still use a standardised approach. For example, if it's tree canopy cover, we have standards for that. If it's density of arboreal marsupials, then in Queensland we have standards for that. I guess that was my plea, but yeah, that's a good question.
That's good. I think that is everything, except that everyone seems to be very happy, and we'll keep in touch. We have recorded the seminar, so we will probably make that available to people shortly. Thank you everyone again for your time. We'll see you next year.